on next part, we have to see about type 3 equations of the form z comma p comma q. Okay, so your question will be in the form of f of z comma p comma q. So for z you will take it as f of x plus ay. This will be your solution, and that x plus ay will be your u. So you will get z is equal to f of u. Now x plus a by u, first you have to partially differentiate it with respect to x. So dou u by dou x is equal to 1, and likewise if you partially differentiate with respect to y, you will get dou u by dou y is equal to a. Okay, so let p is equal to, we know that p is equal to, in the previous classes we have find that, right, where p is equal to dou z by dou x. So we have to split this like dou z divided by du into dou u by dou x. We know that dou u by dou x is nothing but 1, so you'll get dz by du. Likewise for q, we know that dou z divided by dou y. How you will split it? You will split it like dz divided by du into dou u by dou y. We know that dz by du is nothing but a function, and dou u by dou y is a. So you will get a into dz by du. Okay, now we have to substitute it in the above equation. You will get f of z comma, for p dz by du, for q dA into dz by du. And now we have to solve this dz by du to get the complete integral. Okay, so dz by du is equal to g of z comma a. You will get a combination of a function that has both z and a. Okay, now we have to split it with dz will come to the left side and other things will go to the right side. So dz divided by g into z comma a is equal to dou u. Now to take it out from the differentiation, you will integrate it to get the final integral. So on integrating dz by g of z comma a, you will get u plus c. Okay, so this integration of dz g z comma a will be your pi of z comma a, and on integrating du, you will get u with the constant c. Okay, then your final answer will be in the form of z comma a is equal to x plus ay plus c, where x plus ay is nothing but your u. Okay, this is your complete integral. If you can see an example, you can understand it. So find the complete integral of z is equal to pq. So in third type we have to solve this. First, z is equal to pq, that is your question. For z will be of the form f of x plus ay. This will be your solution. This x plus ay will be your u, so you'll get z is equal to f of u. And from the previous introduction we know that p is equal to dz by du and q is equal to a into dz by du. Now we have to substitute it in the given question. What is the given question? Z is equal to pq. Z equal to, for p you have to substitute dz by du, and for q you have to substitute a into dz by du. So dz by du into dz by du becomes dz by du the whole square. Now we have to, what we have to do after substituting, we have to split it accordingly to the z term will be on one side and other terms will be on the right side. Okay, so to take it out from the square, okay, you couldn't put it as dz by du the whole square, so you have to put it as d square z divided by du square. No, you shouldn't put it like that, because this is a first order equation with the power of 2. Okay, so to take that power 2, we have to take square root on both sides. Okay, on taking square root on both sides, you will get root z is equal to root a into dz by du. Okay, now what you have to do is this d of z will be on the left side and other terms goes to the right side. So dz divided by root of z by a can be written as root z divided by root a. Root z will be in the multiplication there. When it coming to the left side, it would become division. So dz by root z is equal to 1 by root a into. Now you have to integrate it, right? So integrating 1 by root z, you will get 2 into root z is equal to 1 by a is a constant, root a is a constant. You will keep 1 by root a as such, where du can be integrated and it will be given as u plus c. Now I'm just reshuffling the things. Root a will be going to the left side, so you'll get 2 into root az is equal to u plus root ac. Here root ac is nothing but you can put it as b, so 2 into root az is equal to u plus b, because c is a constant. I'm just referring it as b here. So on for removing that root, we'll have to take square root on both squares on both sides. On squaring both sides, you'll get 4az is equal to u plus b the whole square. U is nothing but x plus ay, so 4az is equal to x plus ay plus b the whole square. This is your complete integral. Now next question, solve p of 1 plus q is equal to qz. So we know that z is equal to f plus a f of x plus ay. This will be a solution. X plus ay will be your u, and z is equal to f of u, and we know the value of p is dz by du and q is a into dz by du. We have to substitute in the above equation. For p, substitute dz by du into 1 plus q ke a dz by du is equal to, for q, a into dz by du into z. Now I'm just reshuffling the things. The dz by du from left side and dz by du in the right side get cancelled. You will just get 1 plus a into dz by du is equal to az. Next, what I have to do is I'll just reshuffle the things with dz and d other things on one side, so that a dz by du remains here. When this 1 from left side goes to the right side, it becomes az minus 1, and to keep it z on one side and others on right side, I'll keep it as dz by du is equal to az minus 1 divided by a. Now I have to take all the things from left side and right side properly. So a by az minus 1, because in right side it is az minus 1 divided by a. When it's coming to the left side, it would become reciprocated. So on reciprocation, it would become a by az minus 1 into dz is equal to du. On integrating it, integrating of a by az minus 1 into dz, you will get log az minus 1 is equal to, on du you will get u plus b. B is nothing but the constant here. Now I have to substitute the value for u. U is nothing but x plus ay, so log az minus 1 is equal to x plus ay plus b, which is your complete integral. Now solve p square plus q square is equal to z. We know that z is equal to pi of u or f of u, whatever it is, you can keep it as such. And for u, you will substitute x plus ay, and for the p, dz by du, and for q, a into dz by du. Now I'm going to substitute this here, so dz by du the whole square into for p it is dz by du the whole square, plus for q it is a square into dz by du the whole square equal to z. So both the sides will have, in p also there is dz by du the whole square, and q also there is dz by du the whole square. So I'm taking the dz by du the whole square outside into 1, because in p there will be just dz by du the whole square. If I take that outside, it would become 1 plus a square into dz by du the whole square. So if I take that outside, a square alone remains inside. Okay, on taking dz by du the whole square outside, I'll get 1 plus a square is equal to z. Now dz by du the whole square is equal to z by 1 plus a square. To cancel the square, I'll put it as I'll take root on both sides. On taking square roots, I'll get dz by du is equal to root z into 1 plus a square. Everything in the left side and u alone on the right side. So root of 1 plus a square into dz divided by root z is equal to 1 plus a square is nothing but a constant, so you just keep that outside. You have to just integrate root of z. Root of z is nothing but z power 1 by 2. It is in division, so to make it simple, I'm just writing it as in the reciprocated format. Z is equal to minus 1 by 2, so that's what it is written here. On integrating x power n, you get x power n plus 1 divided by n plus 1, right? The same I'm giving here. Z power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 is equal to du. On integrating du, you will get u plus constant c. Now what you have to do is root of 1 plus a square remains as such. Z power minus 1 by 2 plus 1. Minus 1 by 2 plus 1 is nothing but 1 by 2. So z power 1 by 2. Z power 1 by 2 is nothing but root z divided by minus 1 by 2 plus 1, which is 1 by 2. So 1 by 2 on reciprocating, it would become 2. So 2 into root of 1 plus a square into root z is equal to u. You will substitute x plus ay plus b. To remove the root, you will be squaring on both sides. So you will get 4 into 1 plus a square into z is equal to x plus ay plus b the whole square, which is your complete integral. So we have some questions here. Eliminating arbitrary constant from the complete integral is nothing but a singular integral, and for p square plus pq equal to z square, you have to find the answer for both the questions. P square plus that is what I have given, and this is the third question here. P square plus pq is equal to z square, and p plus q is equal to z. Find the answer for this. Thank you.